So with what we do at Portal now, it's even simpler than what we used to do. It's not even microfluidics anymore. It's basically a thin piece of silicon with holes in it. So think of it as a fancy filter, and you're just running cells through that. They get squished. It delivers the material. And this time with our business model, it's just instrument and consumables. So whether it's like academics or biotech and pharma, they can just buy it. And we also have thoughts on how do you think about engineering cells. Like, do you do genetic modifications? Do you do RNA-based modifications to create your new cell? And the way we think about the technical side of this is, right now, if you think of the matrix of what you can and can't do, for nucleic acid cargoes into cell lines, that tends to be pretty easy, hence the green zone. If you try to go into patient-derived cells, that starts to get messy. There's a lot of things you can and can't do. Cells get mad at you because they're not happy after being electrocuted. And then there's a lot of materials that are virtually impossible to deliver, like proteins, peptides, impermeable small molecules. And with our systems, it's the wrong graphic, but with our systems we had shown we can deliver virtually anything we want into any cell type. And that opens up a lot of design space for now what people can do within their cells. So at this point, we've been around for about 1.5 years. We've raised $6 million to date. We're 13 people, but we already have over 35 partners, including 9 of the large pharma. And the reason this has all gone pretty fast is because we're, in a sad way, leveraging 10 years and $400 million of lessons from the past to get this going quickly. But it also illustrates how big of a problem this is for the field, where if you can solve these things, there's a lot of cool new things you can do. And I know the talk was more cell therapy oriented, but there's actually a lot of drug discovery stuff that they're using us for, like drug screening or probing different mechanisms. We think the big ultimate impact is cell therapies, but there's also a lot of research use cases that we've been getting used for. So with that, kind of our long-term dream is, can we enable this to come true, where you're just taking cells from a patient, engineering them on-site to treat all kinds of diseases, and the parts that we want to help support is, can we be the intel inside of how you do this with these various machines? And also down the line, we would want to get into how do you actually think about programming the cells and what are the cargoes you put in there to do this. So if there's any technical side questions right now, please fire away, but otherwise we'll sit down and chat more about the PhD to IPO journey stuff. Yeah.
Maybe on the technical side, I know a little bit of cell therapy. I guess right now they have this thing called in vivo type of thing. Relative to this, do you think that thing is...
So I think the big challenges in vivo faces and may never overcome is, one thing is targeting within the body is extremely hard. So almost everything goes to the liver or the site of injection. That's why if you think about, let's forget about cell therapy, just RNA products, for example. Either it's a vaccine because it just transfects whatever it got injected near, or it's like siRNA or RNA stuff that goes to the liver because that's the default of where everything ends up. Hitting an immune cell mid-flight or going to some other location in the body still is insanely difficult. Let's say someday people solve that. The second challenge with in vivo is it's really hard to load multiple cargoes into the cells. Because if you have 3 things you're trying to put in, if you go in vivo, you're going to end up with single positive cells, double positive cells, triple positive cells, so it gets really messy. So doing any more sophisticated engineering is really hard, but even at baseline targeting is super hard.
Okay, so ex vivo or fast turnaround. Ex vivo sounds like a...
Yeah, and obviously different people have different views on where the space will go, but I would argue if you can do point-of-care cell therapy that's personalized, that is the best way to go. Because it's the most controlled thing you can do, and it's the most flexible in what you can engineer about the cell.